Hi everyone, welcome back to my channel. In this video, I'll be solving this GeeksforGeeks medium level problem called nearly sorted. So in the problem statement, we are given with an array where each element is at most k positions away from its correct position in the sorted order. Your task is to restore the sorted order of ARR by rearranging the elements in place. We are not supposed to use any built-in functions like sort. Let me take this input and explain you how we can do this problem. So this is the input array given. 2, 3, 1, 4. So in the when we take the first index, we need to search from the next k position. Here k is 2. I mean we are supposed to search in next to two elements. So if you see here, one is minimum among all these things. So we need to swap the index element with this one. After performing swap, we will get this array 2, 4. Now we will increment the index. Now we are at 3. Now we are supposed to check at next k indexes, nothing but these two indexes. If we see here, 2 is the minimum element of those 3. So we are supposed to swap these two elements. 1, 2, 3, 4. Now we are at this index, I mean index 3. uh, if we check the next k elements, we need to supposed to check before the length of array. So if we check next element, 3 is minimum than the 4, so 3 will stay here only, and at last 4 will stay here only. So this is the correct answer for this solution. So what is the brute force for this solution? For every index, we need to take a for loop, uh, starts from I to n. Let n be the length of the array, n minus k plus 1. So we need to take another for loop j. It starts from I plus 1 to minimum of uh, I plus k plus 1 comma length of the array. Why? Because if we take this for loop up to n, then we will get the index out of bounds error, because we are supposed to check the next k elements from the array. So if we take these two for loops, and we will perform sorting. If AR of j less than AR of a, then swap the two numbers AR of a comma AR of j. So up, uh, if we submit the brute force solution for this problem, it will definitely fail due to time limit exceeded. So let's implement the solution using Python. So in order to perform the sorting efficiently, we need to use heap queue sort present in the Python. So how we can do this? First, we need to import the module called heap queue. At first, we are supposed to perform the heap sort on first k elements. Uh, it's like this. So heap queue has a method called heapify, which will perform the heap sort colon k plus 1. So what this heapify does is, it will sort the array based on heap sort. After performing this heapify, we'll get the minimum element at 0th index of the array. So after performing this every time, we will get the minimum element of the array in the 0th element of index. So now what we are going to do is, we will take the every k-sized window, and we will do according to that. We will take the minimum element from the heap, and we will replace it with the array element. Let me take a variable called array, and int, and I will initialize it to 0. So uh, now I have already added first k elements into the heap. Now what we need to do is, we have to iterate from the k plus 1 index. So every time what we are supposed to do is we need to pop the element from the heap queue. So heap queue has a method called heap pop. What it will do is it will pop the first element. I mean, first element is nothing but zeroth index, which is the minimum of the heap queue elements present in the array. Heap queue dot heap pop. It will receive the parameter, I mean input called array. Um, oh, so sorry. We need to initialize a separate array with the elements. I mean, like this. Phi for I in range of k plus 1. Uh, so it will take the parameter nothing but a list. So after popping an element from the heap queue, we are supposed to replace it with AR of index. AR of index comma index equal to LE. So we are replacing the element with the AR of, I mean we are assigning the AR of ind with the element, and then what we are supposed to do is we are supposed to add the current element, I mean the this loop element inside the heap queue. It will receive the input array AR, and it will also receive the input AR. So remember we need to increment the index variable by 1. So after doing this, the first n minus k plus 1 elements are sorted, but we need to sort the last k elements, I mean last n minus k plus 1 elements. For that, what we can do is, while there is element present in the AR, we have to pop each element from the AR, I mean heap queue. Sorry, here ARR, not AR. uh, I think this works fine. Sorry, here we need to use heap queue model. So it's passing the sample test case. So it is passing all the sample test cases. Thanks for watching.